So in this example, we are going to continue constructing bar graphs to represent our data. And this says here, for a sociology project, Tessa polled 112 students at her college and asked their opinion about students getting a new tattoo while in school. The table describes the data she collected. Using the data, construct a frequency bar graph and a relative frequency bar graph. So this is the data that Tessa had collected. So she's got these categories here, these student opinions here, strongly agree, and of course she found 43 strongly agree. Agree, she found 20 agree. Neutral, 29 said neutral. Disagree, 16 disagreed. And strongly disagree, there were 4. And of course, if we add up the 43, 20, 29, 16, and 4, it'll come out to be 112 students that Tessa had polled. So this should come out to be 112. She also has a relative frequency distribution here. The 38.39%, well, that's 43 out of the 112 that strongly agree. 17.86, well, of course, that's 20 out of the 112 that agree. And of course, you did that for each category. And if we sum up all of these values here, this should come out to be 100% because everybody has been accounted for. So now we're going to take this frequency distribution and this relative frequency distribution, and we're going to summarize it via a graph pictorially. Except we're going to do it a little bit different this time than what we've done before. So the first thing we're going to do is we're going to put in our horizontal line here. And then we're going to do our scaling here. We're going to do our frequency here. Now, as you do this scaling, I can see that the smallest value here is 4, and then the tallest value is 43. So I don't have to go much further than 45 or 50. And it's just a judgmental thing. It's an objective thing as far as exactly how you want to do your scaling. You just have to make sure that you get everybody included in there and it represents our data clearly enough. So I'm going to do this in 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. That's good. And I'm just going to go ahead and mark it off here. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. I know I'm high enough because the largest data is 43 here. So I'm just going to go 10, 20, 30, 40, and 50. Now all I have to do is put in my bars. I've got 43 that strongly agree. So we'll go all the way up here. Here's 40, a little bit more. There's 43. It doesn't have to be perfect or exact, but it should be close enough to give a nice representation of what's going on. I'm going to label this as SA for strongly agree. Agree, there's 20. That's right here. So here's our agree. Neutral, that's 29. That's a little bit below 30. So here's our neutral. Disagree, that's 16. 5, 10, 15, 16, a little higher. How's that? This is our disagree. I'll label that as a D. And strongly disagree, there's 4. That's a little less than 5 here. So this is our strongly disagree, our SD. So there it is. It's clear enough to give a nice representation of our frequency distribution. So for our relative frequency distribution, if I was to draw another graph, it's going to look exactly the same, except our scaling is going to change. So rather than draw another graph that's going to look exactly the same, what we could do is I'm just going to label the top of this bar up here with the relative frequency of 38.39. So now not only can I see numerically the frequency of what's going on, via the scaling here, but also topped out, I just go ahead and list the relative frequency. And I'm going to do that for each one of these. And this is perfectly fine to do it this way. As a matter of fact, I like it this way because you wind up killing two birds with one stone, right? 25.89%. 14.29. And then 3.57. And again, I can see what the numbers are and I can see what the proportions are. So this tells a good summary of both the frequency and the relative frequency distributions.